my previous video I covered two tools of GROMACS package which can be used to extract useful data from your simulation files. Specifically, GMX dump is used when you want to convert your binary files into human readable form, or when you want to enrich your plain text files with additional information. GMX report methods tool is used to extract general information on your simulation from the portable binary run input file. In this video I cover another such tool, GMX check tool, which main purpose is to check your simulation data for errors and to compare different files, their content. GMX check can be used on the trajectory files, portable binary run input files, energy files, and files with index groups. Let's start with trajectory files. To analyze a single trajectory, you provide the relative path to it with f argument. Here I also tried to save the LaTeX file with output, but I found that it is no longer supported. Here the output is brief, so it makes sense to cover it right now. When no errors were found, it outputs items in your trajectory, the number of frames at which those items are present, and the time step. In case of coords, velocities, and forces, this time step means how often they are saved during the simulation. In this trajectory and in most trajectories I only store coords, as the velocities and forces are of no use. But for unexpected cases, like when the checkpoint file is lost during simulation and you need to continue, you might want to store those. In addition to single trajectory, you can also provide a run input file, and in this case I redirect output and both std_out and std_error streams into one file. When you provide both trajectory and run input file, the program verifies consistency between them, like the box dimensions, number of atoms, whether or not velocities and forces should be stored according to the MDP file which you use to generate run input file, and that kind of information. In case of two trajectories, like here with NVT and NPT trajectories, the GMX check tool compares them frame by frame and outputs any differences that occur between them. This is useful when you want to confirm that two simulations produce the same trajectory with little or no differences when, for instance, you are checking reproducibility of some settings. Similarly, you can compare two simulation setups by providing two portable run input files. From now on, I redirect std_out, std_error streams into different files to avoid mixing them. Also, it is possible to check for errors a single portable run input file by providing it with C argument to command line interface. Inside such TPR file, program checks atom coordinates, clashes between atoms, whether or not atoms lie outside of the simulation box, and alike. It is possible to check the content of a single EDR file, or you can also find the difference between energy terms of two EDR files frame by frame. Finally, you can also check the index file. Now let's check the data from the redirected std_out, std_error streams. As you remember, I initially redirected both streams into one file, but later I tried to separate them to avoid mixing things up. And then I found the two kind of behave strangely in some cases, by, for instance, outputting general info into std_error stream. The output itself seems to be correct, so I don't think that it is such a big problem. I am still at GROMACS 2025.2, so later I will check it on the newer version of GROMACS, but for now I have to stick to this one as I am working on some project. The content of files is self-descriptive, and we have already briefly covered what GMX check does with different kinds of input. So I think we will just briefly look at the file's content here. The files resulted in trajectories analysis are truncated and only contain first few frames, as such analysis can take quite a lot of space and time depending on the size of trajectories, but it should be enough for you to understand what the program outputs for each frame. Yes, the outstream was totally empty, and thus the file is empty, and everything was outputted into the std error stream. This is not the output file, I just wrote down commands I used in this video, and I will also add them to the description. Thank you for your time.